Hello, everyone. For today's lesson, we're going to be talking about chapter 1.3, adding rational numbers. Your essential question is how can you use what you know about adding integers to add rational numbers? So we briefly started talking about this in 1.2, and now I'm actually going to go over the specific rules. And so like I did in the last chapter, just more in detail. How do I add integers with the same sign? So in 1.2, I told you all that if integers have the same sign, we are going to add them and keep the sign the same. Well, this is just reiterating that. Add the absolute value of the integers, then use the common sign. So, for example, 2 plus 5 is equal to 7. Or if we have -2 plus a -5 is also equals -7. If I have 2 negatives and then I give you 5 more negatives, in total you have 7 negatives. The way to remember, same signs add, keep the signs of the numbers the same. So this is a positive, this is a positive. I'm going to add them, keep the sign the same. This is a positive 7. This is a negative, this is a negative. Because the signs are the same, I'm going to add them and keep the sign the same. So this is a -7. Okay, here's an example. So before I do anything, I see fractions, and I know that some of us get scared when we see fractions. But let's ignore the fact that they're fractions for a second and just go off of our rule. So this is a negative. Okay, this is also a negative. So they are the same signs. So I know the same signs add, and I'm going to keep the signs the same. So my answer, I know because these two are negative and my sign doesn't stay the same, I know that my answer has to be a negative. Now, let's go ahead and look at the fact that this is a mixed number. Okay, so for a mixed number, one of the things that you can do is turn it into an improper fraction. And I'm going to remind you how to do that in case we have forgotten. So, I forget about the negative for a second. I know that's going to go in front. I'm going to take the 1 and 1/5. Okay, so I have 1 and 1/5. Here's my next number. Well, to turn this mixed number into an improper fraction, I'm going to take my denominator and I'm going to multiply it by the whole number. All right, so 5 times 1 is 5. And I'm going to add, let's try that again. I'm going to add the numerator. So 5 times 1 is 5, plus 1 gives me 6 over, and we keep the denominator the same, which is of 5. Here, now this was a negative, so I'm just going to go ahead and put the negative in front of it. -6 over 5 plus -3/5. These parentheses here aren't doing anything because there is a positive outside of them. So we can just get rid of them. Remember, your denominator stays the same. So I'm going to keep the 5. Same signs, add. So forget about the negatives for a second. 6 plus 3 gives me 9, and then keep the sign the same. So negative 9 over 5 would be your answer. Now, you do not have to turn this into an improper fraction. There is another way of doing this. I can keep this as, because I know that I'm going to have to add, I can keep and I already have the same denominators. So I know that I'm going to add and keep this on the same. So I know that my answer is already going to be negative. I have one whole, so I'm just going to go ahead and keep the whole there. And I'm going to focus on adding these right here. Well, my denominators are the same, so my fraction is going to have 5. And now this is a negative because this whole 1 was a negative. 1 plus 3. Remember, same signs. This whole thing was a negative. This is a negative. So same signs. Add. 1 plus 3 is 4. So negative 1 and 4/5 is actually the same thing as negative 9/5. This is your answer written as a mixed number, and this is your answer written as an improper fraction. Either of them works. Again, you do not have to turn a improper fraction to a mixed number. You can just leave it like this. This is perfectly fine. What I mentioned in the last section is a lot of times we get the answer wrong because you try to switch it back to an improper fraction, and that just messes up your whole work that you've done. Right. So if you already have it like this, you can leave it. If you feel fairly confident that you can turn it into a mixed number, you can try it. I wouldn't recommend it unless it specifically says to write your answer as a mixed number. And again, if I was to convert this into an improper fraction, 5 times 1 is 5 plus 4 gives me 9/5. Negative 9/5. Okay, that was enough for our first example. Now, here are some practice problems that we can try. So let's go ahead and open this up. Okay, so, well, this first one is simple, right? We've been seeing this since you first learned how to count 7 plus 13. If it helps you, you can always write these vertically instead of horizontally, or you can use your fingers. 7 plus 3 is 10. 1 plus 1 is 2. So my answer to this one was 20. Now let's look at something that we're doing. Okay, so this is a negative. This one right here is a negative. Same signs, perfect. All right, same signs means we are going to add and keep the sign the same. So 8 plus 5 gives me 13. Negative 13, because we had to keep the sign the same. Now let's try it over here. Negative 20 plus a negative 15. Same signs, add. Again, it doesn't matter that this is a plus right here. We have to focus on the signs to see if we are adding or subtracting. This is a negative, this is negative, the same sign, so we're going to add them, and your answer is going to stay negative. The same signs you add, you keep the sign the same. So my answer is going to be a negative. 5 plus 0 is 5. 2 plus 1, 3. So your final answer is going to be a negative 35. Okay, so if you need help on any of these, let me know. You can go back and look to see how we have solved these. Okay, so now we've talked about what do you do if they have the same sign. Let's look at what do we do when they are different signs. Okay, how do I add integers with different signs? Well, first, let's take a look. First, we have to pay attention and know that they're different signs. So this 8 doesn't seem to have a positive or negative in front. If it does not have anything, we always know or assume it's positive. Now, this is a plus, but it doesn't matter because the sign we have closest to the 10 is this negative right here. This is a negative 10. Because this is a plus and this is a minus, they are different signs. and different signs, you're going to subtract. Now, if that's still a little bit hard to remember, here's what you're going to do. This is 8 positives. I want you to draw out 8 plus signs. 1, 2, 3, 4, 5, 6, 7, 8. This is 10 negatives. I want you to actually draw out right underneath it 10 negatives. 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, positives and negatives are opposites. So you're going to cancel out a plus with a minus. So these cancel out because they're opposites. Same. Now, all these canceled out because a positive and a negative cancel each other out. What I am left with, if I pay close attention, are these 2 negatives. So your answer is -2. Way to remember, different signs subtract, keep the sign of the bigger number. So as you deal with bigger numbers, or the more that you do these problems, you're going to get tired of drawing every single time. If you are struggling with these, I highly suggest that you actually draw them. But I know that drawing is going to get tedious and we're going to get tired. So until we are doing well with these, I want to see us drawing them, especially if you're getting these wrong. A way to remember this so that we don't have to draw this every time. If this is a positive and this is negative, I'm going to subtract them. 10 minus 8. Well, I know that's 2, right? This is something that we've been doing since elementary school. Now, I'm going to look at the sign of the bigger number. What number is bigger, 8 or 10? Well, okay, 10 is the bigger number. And what sign does the 10 have? Well, 10 has a negative. So this means that my answer is a negative. 10 minus 8. All right, gives me 2. The 10 was the bigger number, so this is a -2. All right, perfect. Let's go ahead. And let's go on to what I believe will be the final practice problem. Okay, so this is the final practice problem. Let's go ahead and let's try these, right? Let's try this one more time. Okay, so okay, now here's where this gets a lot of people confused. Because it says add, a lot of you think, well, I know how to add. 2 plus 11 gives me 13. So the answer to this is 13. Well, that's actually incorrect. And the reason why is that this is not a 2. It looks like a 2, but it's not a 2 because of this right here. This is a -2, right? And that's a lot different, right? It's actually the opposite of a 2. It's on the opposite side of the number line. A 2 means that you have $2. This right here means that you owe somebody $2, right? You making $2 and you owing somebody $2 is not the same thing. So now let's go over it. If we know that this is not 13, well, let's figure out what it actually is. All right, well, let's identify our signs first. This is a -2, so I know this is a negative. This is a positive 11, so this is a positive. Well, because these are different signs, actually subtract. So let's do 11 minus 2, 10, 9. Okay, this is a 9. Let's keep the sign of the bigger number. So this is a negative. The 11 is the bigger number, and the 11 was a positive. So your answer is a positive 9, or you can just leave it as a 9, right? We typically don't write a plus in front of it, right? We just leave it as a 9. So this would be correct. Okay, well, now that we did that one, let's look at number 5. Okay, well, let's see. This does not have a minus in front of it, so this is actually a positive number. Plus, in parentheses, I have a negative 10. So that 10 is actually a negative. Well, look here. Positive, negative, they are different signs. So I'm going to go ahead and subtract them, right? Well, let's see. Let's go ahead and switch color. Let's do 10 minus 9. Again, this is something we've been doing since elementary school. Use your fingers if you need to. 10 minus 9 is just a 1. And now I have to keep the sign of the bigger number whenever I subtract. So the bigger number is 10. The 10 is negative, so my answer is a negative 1. If that isn't making sense, if you needed to see that, just go ahead and rewind it. Here's what we're going to do. 9 is a positive. So I'm going to draw 9 pluses. 1, 2, 3, 4, 5, 6, 7, 8, 9. This 10 is a negative. So I'm going to draw 10 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Anytime I see a positive and a negative, they're actually going to cancel each other out. So because they are opposites, these cancel, and that's why I put them on top of each other. So or one above the other, so it's easy to see when they cancel. Well, look what I'm left with. I am left with 1. The green was negative, so I'm left with negative 1 as your answer. Make sense? Okay, so now what I'm going to do, I'm going to clear this page to try this last one. This is a review from last section. First, I'm going to see that this is a negative. And the next one right here is plus 27, so this is a positive. Remember, this is telling me that I am going to subtract these. Okay. Well, the problem, if you remember from the last section, the problem with subtracting is that we cannot subtract fractions unless we have the same denominator. So I'm going to try to find their least common multiple, known as the LCM. So I'm going to count by 7s, count by 14s, and see what is the first number that have in common. So 7 times 1, 7. 7 times 2, 14. Add another 7, 21. So 7 times 1, 7. 7 times 2, right, is 14. 7 times 3 is 21. 14 times 1, 14. 14 times 2 is 28, and so on. Now I'm stopping because if you noticed, I already have two numbers that are the same. Their least common multiple is 14. So lucky for me, this is already 14. So now I just have to try to turn this one into a 14. Well, we did that by multiplying by 1, 2. Multiplying by 2. Whatever I do to the bottom, to the denominator, I'm going to do to the numerator. Okay, and now I'm going to write out the fractions that I have. Plus 2 times 2 is 4 over 7 times 2 is 14. Perfect. Now let's go ahead and solve this. Remember, 14, I'm going to write the denominator first because it stays the same. Now here's where I have to be careful. Remember, I am going to subtract these because we determined at the beginning that I was going to subtract them because they're different signs. So 9 minus 4, I know is going to give me 5. The last thing I need to figure out which number was bigger, the 9 or the 4. Well, the 9 is bigger, and look, the 9 has a negative, so I'm going to make sure to put that negative right there, because when I subtract, I have to keep the sign of the bigger number, right? That was our rule whenever I am subtracting. Different signs subtract, keep the signs of the bigger number. So negative 5 over 14 is my answer. This is actually in simplest form, so we can leave it like this. And we'll talk more about simplest form later on. Okay, looks like that concludes, right? The lesson for today. We're now going to go ahead and work on Big Ideas 1.3. If you have any questions, just let me know. And if you need to go back and look at this video and pause it, rewind it, you can as well, right? Let me know if you will have any questions.